Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today I want to discuss about the Green's theorem. This is the theorem, important theorem in vector integration module. So how to calculate the line integral and by using the Green's theorem, and how to calculate the work done by using the Green's theorem, and what is the relation between line integral to surface integral. These details we can discuss and we can know in the Green's theorem. So first of all, I am going to in detail about what is the Green's theorem, so who found the Green's theorem, and what is the statement of the Green's theorem, how we can evaluate the given problem by using the Green's theorem. These are the things we are going to discuss now. So see here, Green's theorem. So Green's theorem named after English mathematician. That mathematician name is George Green. So here this theorem states that the value of a double integral over a simply connected plane region. So here this double integral over a simply connected plane region is determined by the value of a line integral. This double integral value we can calculate by using the line integral around the boundary of R. So here we can observe the figure. This is the region R. Okay. So we can calculate this double integral value along through line integral also, and we can calculate by using the surface integral also. How we can calculate? What is the relation? We are going to see. See the definition or statement of the Green's theorem. Let R be simply connected region with a piecewise smooth curve C, oriented clockwise direction. So if M and N have continuous partial derivatives in an open region contain R, then integral m dx plus n dy. Here we can observe here single integral over curve C. So m dx plus n dy equal to double integral. So here we can observe this is the simple integral, that is equal to double integral. How we can see this? So double integral over R, this is dou n by dou x minus dou m by dou y into dA. So dA means nothing but area. Here we can take dx dy. So area is we can calculate like this by using dx and dy. dA is equal to dx and dy, or dy and dx, or dz and dx based on the given. So here this is the relation between the line integral to surface integral. This is the statement of the Green's theorem. We have to remember this statement. In here, what is the m and what is the n, we have to identify. After that, we can calculate the dou n by dou x and dou m by dou y to calculate the area by using the surface integral or the along the line integral. Now, we are going to know this statement, how we can implement in the problem. So, see the problem now. Use Green's theorem. Here they are giving the particular word, use Green's theorem. If they didn't given the word use Green's theorem, we can calculate the given line according to the problem by using the line integral also. But here they are asking use Green's theorem. So that means we should use the Green's theorem statement now to evaluate the line integral. What is the line integral they given here? Integral C y cube dx plus x cube plus 3x y square into dy, where C is the path. What is that path? From 0, 0 to 1, 1. Along the graph, what are the graph they are giving here? Y equal to x square, and from 1, 1 to 0, 0, along the graph y equal to x. So here 0, 0 to 1, 1. So they given y equal to x square, and 1, 1 to 0, 0, that is y equal to x. So here given points are 1, 1 and 0, 0. So the given directions is 0, 0 to 1, 1 or 1, 1 to 0, 0. So here the graph is y equal to x square and y equal to x here. So first of all, what is the given data? So what is the given data? We are going to see now. After that, how we can evaluate the given integral by using the Green's theorem, we can see. So first of all, so according to the given data, what we should do? So here, by using the graph, given data. So given what they given? They given the graph y equal to x square, and one more graph is there, that is y equal to x, and they given the points along the path, so that is 0, 0 and 1, 1. So one graph is from 0, 0 to 1, 1 and another graph is from 1, 1 to 0, 0. Now what we have to integrate? We have to calculate. So what we have to calculate here? Integral over c y cube dx plus x cube plus 3xy square into dy. 3xy square into dy. So this value we are going to evaluate by using the Green's theorem. That means we should know about the statement of the Green's theorem. So then only we can identify and we can calculate by using the Green's theorem. So what is the values we are going to know from this is, first of all, from the given curve. So along C, y cube dx plus x cube plus 3xy square into dy. So here this is in the form of m dx, integral over c m dx plus n dy, m dx plus n dy. So this is the statement. First we should know. So what is the statement of the Green's theorem? Already we saw here. See, integral over c m dx plus n dy, double integral over r, dou n by dou x minus dou m by dou y into d. So this is the statement we are going to use now. So that one, according to that, so given integral is here, we can compare with the m dx plus n dy. So m equal to y cube, that is only we wrote here, m equal to y cube, and n equal to x cube plus 3xy square. So n is x cube plus 3xy square. So from this, according to the statement, what is the statement? Integral over c m dx plus n dy equal to double integral over r. This is dou n by dou x minus dou m by dou y. So to calculate this value, we should know about the what dou n by dou x and dou m by dou y. So how we can calculate dou n by dou x and dou m by dou y? If you know the values of m and n, then only we can calculate. So see here, already we identified the m value and n value. So now we are going to calculate dou n by dou x and dou m by dou y. So m equal to, we got here, m equal to y cube and n equal to x cube plus 3xy square. So m equal to y cube. So we are going to calculate first dou m by dou y. So here we are doing the dou m by dou m is partial differentiation with respect to y. We are doing for the m. So here y cube is there. We are going to do the partial differentiation with respect to y. So differentiation of y cube is 3y square. That means differentiation of x power n is n into x power n minus 1. According to that, so we are doing here y cube. That means this is 3 into y power 3 minus 1. This value is equal to 3y square. So this is dou m by dou y value is 3y square. So now here dou n by dou x we need. Dou n by dou x. So what is the x value? N value x cube plus 3xy square. So dou n by dou x equal. Now we are going to do with respect to x. So x cube differentiation is 3. According to this, same we can replace here. So formula is derivative of x power n. So according to that, derivative of x cube is 3 into x power 3 minus 1. Nothing but this is 3x square. This value is 3x square plus here 3xy square is it. 3y square. Here 3 is the constant and y also constant. So already we discussed in the partial differentiation. So when you are doing the partial differentiation with respect to x, y is treated as constant. And if you are doing with respect to y, if x is there, x is treated as constant. That basic one you should remember. So here 3 also constant and y square also constant. So derivative of x is, according to this formula, this value is 1. So derivative of x is 1. Now finally I got this is 3x square plus 3y square. So dou n by dou x value is 3x square plus 3y square and dou m by dou y value is 3y square. So now we are going to use the statement to replace these values. So see here, integral m dx plus n dy equal to double integral over dou n by dou x minus dou m by dou y into d. So here m value is given integral is integral over c y cube into dx plus x cube plus 3xy. So this is a given integral. This value we are going to see. So we are going to calculate now. See here, this one is equal to double integral of dou n by dou x minus dou m by dou y into d. So this already we calculated dou n by dou x and dou m by dou y. This we are going to replace here. So this one is here double integral over r. So dou n by dou x value. What is the dou n by dou x value? 3x square plus 3y square. This is we are seeing here. 3x square plus 3y square. Next one is here minus dou m by dou y. Dou m by dou y is 3y square. We are going to replace here minus 3y square into dA. So 3y square, 3y square will be cancelled. So this is double integral 3x square e value, dA value is here we are doing around there with respect to x and y. So we are writing here dx dy. So here dx dy is there means we are going to know about the limits here. How to know about the limits? We can observe here they given the two curves y equal to x and y equal to x square. So according to the parabola we know about the y equal to x square. That is this one is y equal to x square. This is y equal to x square. And y equal to x is the line passing through the horizon. So this is the y equal to x. So this we are taking as C1 and C2. So this is the one curve. This is the one curve. So they given the points from 0, 0 to 1, 1. So they given the data here in the problem. So 0, 0 to 1, 1 is y equal to x square. So here we can observe 0, 0 at the O. We are having 0, 0 to 1, 1. This is y equal to x square. We are taking this one as a C1 curve. Next one is they given from 1, 1 to 0, 0. So that means here from 1, 1 to. So they given the direction like this direction. So here 1, 1 to 0, 0. So this is the curve we are taking as C2y equal to x. Now we are going to calculate along like this. So according to this data 0, 0 to 1, 1. So first we are taking here the y value. What is the y value they given? Y equal to x square and y equal to x. Two curves we have. So that means we can take the curve is y equal integral. Y limits are we are taking y limits are x square to x. Y limits are x square to x. So here we know the point about here. So x limits are 0 to x equal to 0 to x equal to 1. So y equal to x square to y equal to x and x limits are 0, 1. So now we are taking the limits here. So integral So first we have to write outside constant limits. So 0, 1. These are the x limits. And here these are the y limits. Y equal to x square to y equal to x. That means first we should do with respect to y. So that's why we are writing first here dy. After that dx. So what is the value after calculating the final value? We got here 3x square. 3x square. Now this is the integral 0 to 1, integral y equal to x square to x, and calculated value is 3x square dy dx. 3x square dy dx. So this value, this is only we wrote here. So if we know this after this data, this data we can get from the graph and we can get from the given values. So now we can use the integral part and integral formulas to calculate this integral. So here first, here these limits are y limits. That means we have to do with respect to y first. So that's why integral 0 to 1. So 3 and x square both are constants. So integral x square to x into dy into dx. In this way we can write. If you know that clearly about the integration, so no need to separate. For your understanding only, I am separating the integral here. So that means first we have to do with respect to y, after then with respect to x. So it will be clear to you, then we can skip that step, directly we can write that value. So you should know about the integration formulas perfectly, then only you can evaluate this integral. So here integral 0 to 1, 3x square. So integral dy is y. This is the integration formula. So what are the limits we are having here? The limits are x square to x into dx, x square to x into dx. Now we are going to replace here. So this is the step we got up to this step. So we are going to simplify this step now. So this one integral 0 to 1. So 3x square. So integral already calculated, integral dy is y. So y limits are x square to x into dx, x square to x into dx. So now here integral 0 to 1, 3x square. So upper limit minus lower limit we are substituting here x minus x square into dx, Now integral 0 to 1, 3x square into x. 3x square into x is 3x cube minus 3x square into x square. This is 3x power 4 into dx. Now we are going to do the integration individually. So first term and second term. So now we got the terms in terms of x. So that's why we can do integration with respect to x. Then we can substitute the limits here. So 3 is the constant, taking out. So we are doing individual integration here. So 3 integral 0 to 1 x cube dx minus 3 integral 0 to 1 x power 4 dx. Now 3 into integral x cube. So already we know the integration formula. So integral. So we discussed before about the differentiation formula is the derivative of x power n is n into x power n minus 1. Here integral x power n is x power n plus 1 by n plus 1 by n plus 1. So now, 3 integral x cube. So this is x power 4 by 4. So limits are 0 to 1. Minus here 3 into integral x power 4. That means this is x power 5 by 5. The limits are 0 to 1. Now we are going to substitute the limits here. So 3 by 4 is the constant. So limits are 1 minus 0. Minus here also 3 by 5 is the constant. Here limits are 1 minus 0. So finally this is 3 by 4 minus 3 by 4 minus 3 by 4. So this is 4 5s are 20 here. So now here 5 3s are 15 minus 4 3s are 12. So this is the 3 by 20. So this is the final answer. This is the final answer. If you take in y equal to x cube, then it will be different here. Final answer. So this is x cube. Then we will get the answer like this. So x cube by, if y equal to x cube and y equal to x cup is there, then we can get the answer like this. That is 1 by 4. Here we are getting here x power 6 by 6. So 1 by 6 will get. So here this will be final answer. So this is the way, by using the Green's theorem, we can calculate the line integral. So directly we can use the line integral also. Otherwise we can do like this by using the surface integral also. So for every problem, the solution will be same. But how we can evaluate? By using the line integral also we can get the solution. By using the surface integral also we can get the solution. But which one is simple according to the given problem? For some of the problems we can calculate the line integral easily. But if you calculate the line integral, we have to do along the C and along the C2. So here we can observe. So if you are calculating by using the line integral, we have to do first along C1, after then along C2. So then we have to do the two parts and then you can calculate this. So if using the surface integral like this, so there is no extension problem. So directly we can calculate like this. We can simplify the problem very easily. This is the importance of the application of the Green's theorem. So I hope you got the clarity about the Green's theorem, how we can evaluate the given integral by using the Green's theorem. So now I am moving to one more example to get a better understanding about the Green's theorem. See the next problem. While subject to the force, what is the force given? F bar of x comma y equal to y cube into I bar plus x cube plus 3xy square into j bar, and a particle travels once around the circle of radius 3 before the given two curves. So y equal to x square and y equal to x. Here the given particle travels once around the circle of radius 3. So the given one circle, so with radius 3. So what we have to do, use the Green's theorem to find the work done by F. So here we have to use the Green's theorem to calculate that work done. So first of all, as like a previous problem, we are going to know what is the data they given, and according to the Green's theorem statement, what are the terms we need, first we will calculate. Is it clear? So now see. So what is the given data we are writing first? So given that the force is given, that is F bar of x comma y, that is y cube into I plus x cube plus 3xy square into j, Now we are using this F. By using this F, we are going to know about the what is M and what is N. Why we need this M and N? What is the statement of the Green's theorem? Integral over C, M dx plus N dy is equal to double integral over R, dou N by dou x minus dou M by dou y into dx dy. Otherwise, dA is nothing but dx dy. So, according to the statement of the Green's theorem, we should know about the M value, N value, and dou N by dou x and dou M by dou y. So, what is the M? By using F, we can take this value. We can observe here, we can compare this one by giving the 4. So, here M equal to, in the form of M dx. So, how here they given I bar and J bar. So, this is the F. So, we can write this F bar dot dr bar. We can know here, just a minute. So, actually in the previous problem, they given in the form of y cube dx, that is nothing but m dx form. So, directly we can take an m value. So, here they given the force, that means vector they given. So from this vector, how to identify the m value or how to identify the n value, you can see here. So f is given here, and already we know about the dr. What is the dr? Dr is nothing but dx into I plus dy into j. So dx into I, dy into j. Now we are going to do this f bar dot dr bar. So f bar dot dr bar is, this is the f bar, y cube into I plus x cube plus 3xy square into j. This is the f dot dr value. What is the dr value? Here dx into I plus dy into j. So by using this, we are going to do the dot product now. First one. So here y cube into I and dx into I dot I is 1. So finally this is y cube into dx plus. Next, second term, the x cube plus the x square y, 3xy square into dy, and j dot j is 1. So finally this value is x cube plus 3xy square, x cube plus 3xy square into dy. So this is the final value of r dot dr. Now we can know what is the m value. M equal to y cube and n equal to x cube plus 3xy square. So here m dx plus n dy. So m value is m dx form. So m value is y cube and n dy form. So n value is x cube plus 3xy square. So here we know about the m and n. So if we know the m and n, according to the statement, we can find out the dou n by dou x and dou n by dou y value also. Now, m value is m y cube and n value is x cube plus 3xy square. So by using this, we are going to calculate dou n by dou x and dou n by dou y. So here m is y cube and n is x cube plus 3xy square. So dou m by dou y. So now here partial differentiation of m with respect to y. So this is y cube, that is 3y square, that is 3y square. Next, n equal to x cube plus 3xy square. So dou n by dou x equal to, now I am doing partial differentiation with respect to x. So this is a differentiation of x cube is 3x square plus 3y square into x is 1. So finally, dou n by dou x value is 3x square plus 3y square. Dou m by dou y value is 3y square. Now, we are going to use these values in the statement. What is the statement? Integral y cube dx plus 3xy square into dy. So here, this value is equal to double integral over r dou n by dou x minus dou m by dou y into dA. So here we are going to replace these values here in the statement. So up to now we gathered the data from the given problem and what are the values we need to evaluate the integral by using Gauss theorem. That all values are recalculated. Now we are going to replace these values in the integral. You can see here. So double integral over r. So dou m by dou value is 3x square plus 3y square. Here minus dou n by dou x. Dou n by dou x value is 3y square again. So here into d. So this 3y square and 3y square is cancelled. So finally I got here double integral over r 3x square into d. 3x square into d. Now we are going to see here this one. So how we can get this dA value? Before in the previous problem, we given two curves y equal to x square and y equal to x. Based on that and based on the points also 0, 0 and 1, 1, we taken the limits of x and y. We taken the limits of x. Now they didn't given that data, but they given. So one circle is there of the radius 3. So that means we know the values. We know the values, radius value is 3, we know. So the given circle, radius is 3. And when you are taking the circle here, we can calculate this area value by using the polar coordinates. So if we know the r limits and theta limits, we can calculate. So radius are equal to 0 to 3. Now what about the theta? So given the circle, that complete circle, that angle is 0 to 2 pi. So according to that, we are taking according to the polar coordinates, we are taking x equal to r cos theta, x equal to r cos theta, and that we given the radius r limits also, that is 0 comma 3, 0 less than r less than 3, and for the theta 0 less than or equal, theta less than or equal to t pi. So here what is the dA? What is the dA is r dr d theta, r dr d theta. So if we know these three values, we can evaluate this integral very easily. Why we are taking r and theta? They only given the circle here with radius 3. So now, we are going to take the values r equal to 3 according to the given problem. So I hope we got the point why we are taking here radius 3 and the limits are r equal to 0 to 3 and theta limits are 0 to 2 pi. So now by using these limits, we are going to evaluate this integral, that is work done equal to double integral. Work done equal to double integral over r 3x square dA. So now we are going to use the r and theta limits. So already we know what are the constant values we have to take in the final stage, that's 0 to 2 pi and r limits are 0 to 3 and here 3x square into dA. So here dA means already we know that we are replacing here r dr d theta. So all values we should convert into in terms of r and theta. So that's why in place of x we are writing the r cos theta. So what is the x square value? X square value is r cos theta whole square. R cos theta whole square. What is this value? R square into cos square theta. R square into cos square theta. So here that value we are replacing integral 0 to 2 pi and integral 0 to 3. 3 into x square value is r square cos square theta, r square cos square theta into r dr d theta, r dr d theta. So now this value we are going to see here. This is double integral. This is 0 to 2 pi and r limits are 0 to 3. So now constant value what we are having here, 3 into cos square theta, 3 cos square theta, and here r square into r. R square into r is r cube into dr d theta. So that means these are the both are constants. So you can do with respect to r with respect to theta. So anyway we can do both values because both limits are constant. So first I am doing with respect to r here. So integral 0 to 2 pi, 3 is the constant, taking out cos square theta, integral r cube dr. R cube dr is r power 4 by 4. Limits are 0 to 3 into d theta. Now we are going to replace the limits here. 3, 4 is the constant, 3 by 4 is the constant. Otherwise, you can keep it as it is to get the simplification easily. So anyway, you can take it out also, you can place there also as you wish. Okay. So integral 0 to 2 pi cos square theta. So here r value, that is 3 power 4 by 4 and here upper limit minus square limit 0. So into d theta. Now 3 power 4. 3 power 4 into 3. 3 power 5 by 4. Integral 0 to 2 pi cos square theta d theta. Cos square theta d theta. So 3 power 4, 3 power 5 by 4. This value is 243 by 4. And integral 0 to 2 pi cos square theta d theta. Cos square theta d theta. So what is the formula? Directly you can do the cos integral cos square theta. That's why we are changing by using the trigonometric formula. So cos square theta we can written as 1 minus cos 2 theta. So that's why we are replacing here 243 by 4 integral 0 to 2 pi. So cos square theta I am writing as 1 minus cos 2 theta by 2 into d theta. 1 minus cos 2 theta by 2 into d theta. This value we are going to simplify here. So 243 by 4 and 1 by 2 is the constant, taking out integral 0 to 2 pi 1 minus cos 2 theta into d theta. So finally this value is 243 by 8, 243 by 8. So now integral 0 to 2 pi 1 minus cos 2 theta into d theta. So now this is 243 by 8. Now I am doing the integration. The partwise here. So here integral d theta, limits are 0 to 2 pi. I am separating the terms here. Minus integral 0 to 2 pi cos 2 theta d theta. So here this one 243 by 8. 243 by 8. Integral d theta is theta. Limits are 0 to 2 pi. That is only we got here. Integral theta minus integral cos 2 theta. What is the integral cos 2 theta? Sin 2 theta by 2. Sin 2 theta by 2. So these are the integration formulas you should remember. So integral cos 2 theta is sin 2 theta by 2. So that is only we are writing here. The limits are 0 to 2 pi. Limits are 0 to 2. Now we are going to replace the limit. So 243 by 8 is the constant. So first one upper limit minus lower limit. So 2 pi minus 0. 2 pi minus 0 minus 1 by 2 into sin 2 theta. So sin 4 pi. Sin 4 pi minus sin 0. Sin 4 pi minus sin 0. Now here 243 by 8 into 2 pi into 2 pi. Already we know sin n pi is 0. Sin 0 also 0. And sin n pi is 0. So that means these two terms are 0. Finally we got 243 by 8 into 2 pi. So 2 cancelled 4 times here. So finally the work done value is 243 pi by 6. 243. This is 243 pi by 4. This is the work done. We calculated by using Green's theorem. So before, what is the difference between the previous problem and this problem is they given their curves y equal to x square and y equal to x. But in this problem they given the circle and radius values. So that's why we used the r and theta limits. R and theta limit, that means polar coordinates to evaluate the integral. That is the difference between the previous and this one. So that's why what is the given data in the question or problem, first we have to analyze. So according to that, we can calculate that integral. If we know the basic formulas or basic definitions or statement of the theorem. So first we have to know about the basic formulas. That's why you should go through the basic formulas to evaluate the integral ACV. Okay, I hope you understand about this problem. Now to get the better clarity, I am going to discuss one more problem based on this Green's theorem. So what is the question they given? We can observe here. Apply Green's theorem to evaluate the integral. What is the integral they given? So that is integral over c xy plus x square into dx plus x square into dy, where c is bounded by y equal to x and y equal to x square. So here they given the curve is bounded by y equal to x and y equal to x square. So this is the y equal to x square curve and y equal to x is passing through the origin. So this is y equal to x square and this is y equal to x. Now along this we should know about the values also. So if you calculated y equal to x square and y equal to x, then we can know about the limits also. First of all, what is the given data we will write. So given that y equal to x square and y equal to x curve, and we are going to integrate this one. So integral over c xy plus y square into dx plus x square into dy. This value we are going to evaluate. So here we are first of all what is the m value and what is the n value. Here, what is the statement of the Green's theorem? First, we should know. So, what is the statement of the Green's theorem? Integral m dx plus n dy is equal to, we can observe here very clearly. So, according to Green's theorem, so integral over m dx plus n dy is equal to double integral over r dou m by dou y dou n by dou x minus dou m by dou y into d. This is the statement. Now, what is the given integral value? We can write here integral xy plus y square into dx, xy plus y square into dx plus what is the value? X square dy, x square dy. So we are comparing with this. So now, according to this, what is m value? M value is equal to xy plus y square. And what is the n value? N value is equal to x square. That is only we are writing here in the form. We can take pi and psi also. So m and n also both are same. Here there is no issue for that. So here they taken pi and psi. So we can take m and n also. So in this statement, we need the values of dou n by dou x and dou m by dou y. So dou m by dou y with respect to y we are doing here. So this one is with respect to y means x is the constant, y is 1 plus here only y is there, so 0. So that's why we got here this value is x minus. So here derivative of y square is we got here 2y. With respect to y we are doing, right? So this is 2y. Now dou n by dou x, with respect to x we are doing dou n by dou x is 2x. So dou m by dou value and dou n by dou x value. So now according to the statement we are going to replace here integral m dx plus n dy is equal to double integral dou n by dou x minus dou m by dou y into dx dy. dy is nothing but dx dy. Now double integral dou n by dou x value is 2x minus dou m by dou y value x plus 2y means minus x minus 2y minus 2y into dx dy. Now we are going to simplify this. Double integral 2x minus x is x. So x minus 2y into dx dy. This is the final value after calculating the m, n and dou n by dou x and dou m by dou y. Now we are going to integrate this integral. That means we should know about the what are the x limits and what are the y limits. How we can get the x limits and y limits? By using the given data only. So according to this figure, how we got the 0, here and 1, 1. So we have to know first here y equal to x square curve is given. In some of the problem they will give the points also 0, 0 and 1, 1. So in this problem they didn't given 0, 0 and 1, 1. So that means we have to find the intersect point also to find out the limits here. So only they given the curves y equal to x square and y equal to x. How we can find the intersecting point now? By calculating or by simplifying this one. So y equal to x and y equal to x square means I can write this one as x square equal to x. So x square minus x equal to 0. So I am taking the x common here, x into x minus 1 equal to 0. So here x equal to 0 and x minus 1 equal to 0. So here x equal to 1. So from the first point, if x equal to 0, what is the y value? Here we got the two values, x equal to 0 and x equal to 1. If x equal to 0, y equal to 0. And if x equal to 1, y is also 1. So now the points are 0, 0 and 1, 1. So that's why we wrote here 0, 0 and 1, 1. So now intersection points are 0, 0 and 1, 1 means. So now we can take the limits here. Y limits are x square to x. X limits are here 0 to 1 we can take to evaluate this integral. Here y limits are x squared to x and x limits are 0 to 1. X limits are 0 to 1. Now we are writing here 0 to 1 and 0 to here x squared to x squared to x. Now the given value is x minus 2y into dx dy. X minus 2y into dx dy. Now we are integrating first with respect to y. So in place of x minus y we can use here. So here xy minus y square. So y value already we know, right? So we can convert all terms in terms of x or in terms of y to evaluate this integral. So see here integral 0 to 1. Integral 0 to 1 here. And here we know about the y square here. So here how can convert this one? We can observe here integral 0 to 1. So x minus 2y. So what is the first one? X minus 2y. So first we are doing with respect to y first. So y limits are x squared to x. So x into with respect to y we are doing. So here integral dy is y. Y is the constant, right? So x squared to x minus 2 into integral y dy is y squared by 2. So 2 will be cancelled. For this limits are x squared to x into dx. Now we are going to simplify this integral 0 to 1 x into x minus x squared. The same way here also, here y squared. So that means x squared minus x squared into dx. Now we are going to simplify this to get the final value integral 0 to 1. This is x squared minus x cube minus x squared. Minus of minus plus x power 4 into dx. So x square will be cancelled. So finally integral 0 to 1 x power 4 minus x into dx. When you are integrating this one and replacing the value, finally we got the value minus 1 by 20. So this is the way we can calculate the line integral or surface integral by using the Green's theorem. Here we observed, in this video we observed 3 types of problems. So first one we given the curves and the intersection points also. And the second problem they given the only circle with the radius. At that time we using the polar coordinates. Now they given only the curves, not given any intersection points. So first we have to calculate the intersection points to know about the limits to calculate the Green's theorem. Okay. So I hope you got the better clarity about the Green's theorem. So we will discuss some more problems in the next video about the Green's theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.